So let me go back because I like to show. So this is the title.
Awesome.
Um, there's actually four things we're going to talk about. I'll get to, but a little bit about myself. So Shane Richards is the name, of course. What I do, probably I'm 7.5 years into it. I've been the USU Landscape Operations and Maintenance Manager. Love it. It's actually, I don't know. I'm hoping to have a career here, end a career here, so to speak. And it's because I get a lot of support and I'm able to progress. My goal is to be have some of the best processes, best conservation in all the colleges in the nation. So I got some lofty goals and I get a lot of support in there. 28 years of experience in the green industry, anything from a park manager, private contractor. I've done 300 or 400 weddings as a floral shop owner, which I guess I don't have that look per se. And it was always funny because when I was a floral manager, I'd sit down to design a wedding and their eyes would go big and like you're doing the wedding, but I have a lot of floral experience. And then I've worked for some business kind of government. The Boyer Company is one of them, the business people of Ogden, where I kind of, like I says, quasi government, quasi private business. So quite a bit of experience in there. My education is USU and Ohio State University mostly. I do have some certificates from like Rutgers or other ones because I like education. Um, and so I go around and kind of will dabble and get a certificate here or there. And then I love plants and dirt, of course, one of my favorite things. I love spending time with the family. And then if it has an engine, I usually really enjoy it. If you guys know right now, my new car for the season is an old Subaru Brat, 1980s, has the seats in the back. It's modified a little bit. I have a bigger engine and stuff like that, but I love that kind of stuff. So this is my university. This was taken in the fall, actually, up on the ag building, kind of across the quad at Old Main, but love the location. A good place to work. We're a little bit higher than the rest of Utah, so we have a little bit cooler weather and some bigger winters. This is one of our trees, probably about a 90-year-old tree on campus. If this plays, I'm hoping it'll kind of play. We went through it technically and it worked okay, but
Yes, it's working. I can see. Yeah.
so this is Old Main. We're about 80 feet tall in the tree. Just a quick thing about PGMS is he mentioned that it's actually not official until next Thursday when they finally are supporting at the national conference of PGMS. But we're already planning, and yeah, it's a new chapter in Utah. Professional Grounds Management Society's been around for about 100 plus years. But it'll be kind of new to Utah. And our first big, we have monthly activities, but we have one big quarterly activity. And so our first one is set for March 20th, 2024 at the USU Bastion Ag Center. And we'll have classes similar to this one. We'll have food. And then I'm excited about the activity. The activity for this one is a lawnmower racing. So if anybody wants to come join us for the classes, for the food, or to come race a lawnmower, this is open to the public. There's actually 5 classifications, anything from the super fast, super modified to the stock old man 8 mile per hour mowers. There's actually a kids one for 10 to 15 years old. So anyway, that's going to be a fun event in March if you want to join us. Just a little I don't know what you call it, a little advertising for PGMS. So starting out, there's 4 things I want to talk about. And so soil irrigation for life is one. I always start out when I talk about irrigation, you got to talk about soil as well. So these are the 4 things. I actually had 5, but I don't think I had enough time to do all 5. And so I took one off. But most of the questions I get about irrigation are fixed by irrigation repairs. Knowing your dirt is a big one that a lot of people kind of ignore or skip over or don't connect with irrigation. Adjusting the clock, and then knowing a few details about the heads. So the 4 things we're going to talk about today: soil and construction, and how that affects the irrigation and how it affects everything. It's pretty much the life of your landscape is affected by what you're doing the construction and what happens with the soil. Um, I know I'm on a couple Facebook groups and I talk a lot about soil and aeration, but that's the foundation of kind of everything. So it goes hand in hand with irrigation. And then we're going to talk about some small adjustments that kind of give a big result, especially when we're talking about efficiency. And then we're going to talk about some irrigation repairs. Mostly I focus in on 3 or 4 of the electrical or the valve issues. Um, And then along the way, and I kind of intermingle it with these other threes, I have some tips and tricks that you can do with the clock. And then if we got time in the end, we'll explore that one a little bit more. The fifth one I took off, that if I start rambling and talking real fast, we'll talk about predicting the future. Um, Looking and using some tools online that can actually help us know whether we're going to be in a drought season or not drought season, or what you can expect in about that February, March time for the year and what you need to do. So effects soils and irrigation. So to start off, soil structure and compaction affects your plants and irrigation for the life of the landscape. So it's not a quick fix. And if it's deep enough compaction, it's really not fixable unless you tear it up and redo it. And so we want to be careful during the construction part. And irrigation soil are forever married. When you program your irrigation, you're programming it for the health of the plants, but a lot of times it's the soil just determining how long, how often, and when. And we'll talk about that a little bit later. So just to start off with compaction, so I pulled this one called the Silent Thief, and I actually just like the graphic on it. This is basically a truck tire, 11 inches by 28 inches, and in kind of the PSI and the pressure it puts on your soil when you drive across turf. Now this happens. A lot of times we think about this compaction issue happening after we planted the grass or after we planted trees, but this happens a lot of times before anything goes into the ground. And I'll have a kind of a picture showing a little bit about that in just a couple slides. But compaction is one of those issues that is kind of on this title. It's called the silent thief. Is for the next 20, 30, 40 years, you could be dealing with issues with your landscaping and your irrigation, and your landscaping not taking the irrigation just because that compaction is pretty deep. And if it's heavy loads, it causes compaction that you can't remedy. You either got to tear it up and redo it. And if you have mature trees and you're compacting around those, it's really hard to kind of correct it. I do have a couple solutions, but we want to be aware of compaction. So this is a good graphic. If you guys have visited my USU campus or not, there's actually trees on both sides of this. You look at that one, actually I don't know what's right or left on your guys' side, but the side with the green tree, probably half of our trees look like that, but we have probably half our trees that look like the other one. They're healthy, they look good, they're tall, they're mature, but they're starting to get a little bit thin. We have to fertilize them. We have to go in and prune out some dead in them every couple of years. We have a couple low-hanging branches. And we keep trying to educate the public and especially the construction companies and people that work on campus that even though you can't see it, there's a long-term damage that happens when that soil gets compacted. It's hard to get water in there. It starts to lock up nutrients, and we actually see this. So we have this beautiful. Somebody made a comment that you guys have a gorgeous 100-year-old landscape, and what we function, or one of the things we view it at, is all right. How are we going to keep it nice for the next 50 years? And over the past 20 or 30 years, we're starting to see some of the decline in some of the mature trees because of the compaction that's happening. And we see this on the grass level as well. There's some turf areas. There's a place on the quad, and I have a picture coming up. That's kind of the center of our campus where we watered once this summer in 19 days because of the activities. And we have 3,000 people on the campus. That one water in 19 days kept most of the quad beautiful and green where we actually have deep root systems. And there's one project about 15, 20 years ago where they put a tunnel in and compacted it. And that's where we started to dry up, and we had to come in and actually put an extra watering on it to keep it green through that summertime. So this one's just quick, and we'll brush over it, but most people know how this works. Compacted soils, that irrigation water is not going to go in as easily or as deep. Or if you got a good soil, it's going to go through the system. So here's the example. So we want to pay attention to the green. There's a pattern, of course, and this is on our Tooele campus. Tell you a little bit about the soil is we have high standards for soil, and we actually have a lot of it. When we put in a new irrigation, or excuse me, not a new irrigation, a new landscape, they're required to put 12 inches of good topsoil in whenever they have turf, and then I believe it's 18 inches to 24 inches where we have trees and where we have shrubs. And so when we do a landscape, a new one, they take off all the subsoil, and it's generally because if you guys have had a home built, they'll scrape off the good soil, and then you're left with just the bad stuff. And so that happens a lot during this construction. So they take everything out and they bring in some good topsoil. So in this turf area, we have 12 inches of really nice topsoil. This picture, and just a note, if you see grass that has this vivid green and then this bright yellow, so this kind of contrast right here, this is turf and recovery. This means it's been watered. That bright green will start to pop, and then that yellow comes out, and so you actually know this has been irrigated. So this irrigation system was broken, and we turned it on and watered the first time on the 10th of June. This is 2018 or 2019. So the 10th of June, it received water, and I took this picture on June 13th, so 3 days after. The pattern, and I'm going to use my mouse, but if you see on these green lines, this is actually where every irrigation is put on the end of these little green T marks. And so the green is actually, after they put the topsoil down, they smoothed it out, they went in and trenched and put the sprinkler system in. So everywhere you got these green lines along the edges and coming out is where there's an irrigation line in. But it demonstrates the difference. And this is probably 4 years, 5 years after the construction. But wherever the soil was loosened, wherever they kind of dug that up and made it a little bit looser, those roots are going deep enough that they sustain basically the grass and keep it green all the way to about mid-June, with no supplemental water, nothing besides what we got in rain that year. And then everywhere else, even though the soil tests really, really great, it's compacted enough that the roots just can't get deep enough or stretch deep enough that it yellowed out. It started to kind of look crisp and die. And then as soon as, it got water, this looked good probably 3 weeks later, but you can tell how well that vibrant, loose soil, and it's not loose enough you're going to fall into it, but it's just not compacted. So it makes a big difference. So we're 13, 14 years down the road from when this was put in, and we're still dealing with the same issues. This takes a lot of aeration. It takes a little bit more watering. If we could have had this soil all around that's in the yellow as loose as where we trenched, we probably only watered 3 to 4 months out of the year, just in the summer months. We wouldn't turn it on until June, and we probably turn it off around that first or second week in September. As is, because we don't have this loose, we'll turn it on sometime around May, and then we'll keep it till the end of September, sometimes into October. So just kind of a big difference. This one highlights, I like how the visual, it shows where the irrigation trench lines are at. And I'm trying to get my skip button to go. All right, we'll do that one. So a couple solutions for it. White footprint when doing construction, that's a big one. And then after construction, because sometimes if you're building a building or a house, there's no choice. You're going to have to bring the machines in. It's going to get compacted. So before you do the landscaping, till it or rip it or replace the dirt and get something that's a little less compacted. Now, a lot of the problems is it's already happened. It's too late. So now we're working on fixing an existing landscape. For lawns, heavy aeration, moderate watering. Watering is kind of a key in there. If you water too much, you're actually going to get more compaction. And if you're watering too little, you're going to actually get some more compaction. So moderate watering, top dressing, and time. Turf actually does a great job over time of kind of tillering and just correcting the dirt itself. Around trees, light drilling, some root pruning. And then one of the most underused practices I've seen around trees and compaction is air spading. And that's this little graphic that's off to the side. Air spading loosens the soil up. And this one shows it's actually, let me see, the vacuum's not as important to me as this little piece right here that he's doing. And it's just compressed air that they're blowing out the lines around the root system. So this one kind of shows it in a little more detail what it'll look like. If you have a compaction around a tree, there's been a lot of driving, a lot of construction, you can actually air spade out some lines, do that over a 2 or 3 period, and it'll decompact that root zone around the trees. I see a lot of trees. I could do a whole other thing on trees burying too deep and compaction, but I'd say the majority of problems I ever see with mature trees dying is because they're either buried too deep, or a lot of times it's because there's a lot of compaction around it, and so the roots will girdle, or they'll just grow on the surface and all that kind of stuff. But if you put some air spading in, go a little bit deeper, that can actually take care of a lot of compactions and give you 100 to 500-year-old tree with a lot less problems. So any questions? I see a Q&A in the chat. I haven't checked them yet, but any questions real quick about soil? We can take 1 or 2 if we want to. if it's easier to do it now so we don't kind of lose before I go to irrigation adjustments.
So, Sen, Mark asked, what kind of irrigation? Was that subsoil drip? The picture you showed where the grass was green when the compaction was reduced and when it was yellow. Yeah, this one. What kind of irrigation?
So this one is just pop-up. So they're about 15 to 18 foot pop-up irrigation heads. So on each one of those areas, there's just a little irrigation head. So in the corners, along the edges, and then every one of those areas. So that spacing between here and here is about 15 to 16 feet.
Awesome. Thanks.
Okay. So
Okay, let's get going.
this is the second part. So irrigation adjustments. When I talk about irrigation repair, irrigation adjustments and irrigation repair kind of go hand in hand. They're fairly interchangeable. So the first thing I talk to people, now some of this I'm gonna be gearing towards the professionals in the industry, and some of this for irrigation repairs and adjustments going to be for professionals and some for the homeowners. So we're going to kind of do a wave of a little bit a bit more advanced, and also a little bit if you're new to it. For irrigation adjustments and repairs, the first step is to sit back, relax, and watch. If it's a big break, you're going to know you're going to have water flooding everywhere, so you can just shut it off and you can go and repair it. But most of the time, and most of the questions you get, if people are like, my grass or my trees are suffering and I don't know why. And you can tell that there was some wilting going on, and they're trying to decide if it's irrigation problems or if it's disease problems. So the secret is just relax a bit. And when I say that, I usually literally mean it. And a lot of times um, when I do some irrigation work on the side is, if it's a big property, I don't want to sit down because it looks unprofessional, but if they know me really well and I've worked with them for years, yeah, they'll actually see me bring out my lawn chair, sit it down, I'll have my notebook, and I'll go through the system and I'll start taking notes. And when I start to see patterns and I start to take some notes, I can identify what's broken, what just needs to be adjusted, and then I can start making a plan from there. So that's what I usually say is relax a bit, take a deep breath, especially if you're kind of new to the irrigation repair, and just watch it and just start taking some notes. And you'll start to see it pop out, and you'll be able to say, all right, this one is just an adjustment needs to be made versus this one, which is broken and definitely needs to be fixed. Or there's usually, like I said, if it's broken, you can usually identify it, but there's something not right and you're suspecting there's something broken. Special tools. If you're new to it again, don't be surprised if you got to take multiple trips to the store. That even in professionals, I mean, I've done it for years and years and years, and sometimes I got to make 2 or 3 trips just because there's always the one tool or the one valve or the one part that I don't have. So don't let that bother you. And if you're trying to decide if you're a DIYer and you're trying to decide whether you want to do it yourself or you want to hire it out, there's a lot of costs in irrigation. I've seen people do as cheap as $25 an hour, all the way up to about $150 an hour. Usually in the Salt Lake Valley up to Logan area, 60 to 120 is that range that I see people working with that have some knowledge in irrigation. Sometimes it's worth it to hire it out, sometimes it's not. So just a comparison. So if you're looking at thinking, all right, well, I want to tackle this, you kind of know what you're saving or what you're getting into. So going into irrigation adjustments. By the way, just to show off, because again, I don't know if everybody's seen the campus. This is the quad. In 2020, we decided to mow an American flag into it. And there's actually some other pictures with better angles where it really pops. But the stars are 14-foot stars. The whole flag was 500 feet by 300 feet. But it was kind of fun. Nobody was really on campus because COVID had shut everything down. So we could do whatever we wanted. So we came up and did some fun creative things as a team. Flower beds, we have about 60,000 flowers we plant on our campus. So this is a fall planting, which we actually started today up here. So we started planting pansies in a lot of our annual beds. So irrigation adjustments. So some general quick rules, 2 of them really. Irrigation heads should not water themselves or the area around themselves. Irrigation is a team effort, right? It works as a team. So you adjust the heads so they can reach out to one another and support each other. That's a general rule. There's always exceptions. I always refer to it as the 98% of the time rule. So 98% of the time, that type of thing, you're going to be supporting and watering each other. The more times an area overlaps, the more efficient the watering will be. And this is true above ground irrigation heads like rotors and pop-ups. And so I put a little note in there is I want to remind you, it's not about giving more water or watering more than you need to. It's always going to be the same amount of water. It's just we're working on efficiency. So if you have an overlap, if you have a point source irrigation where you got a little drip line running to a plant, if you have two of them, you cut your watering time in half. But if one gets clogged, you actually kind of have a backup plan and that kind of stuff. If you're overlapping 3 or 4 spots on a turf area, it's less time, there's a little more coverage, and there's some more efficiency. So keep in mind that when you're building, or if you're a client hiring somebody out, an extra head or two and a little bit of over coverage isn't too bad. It's actually going to help you be more efficient when you're building a system or fixing a system. Okay, so this one, I'm going to play the video. I'm going to pause it, or I might skip through it a little bit because there's a little bit of wind in here. But what I'm looking at is this is an irrigation head that I fixed. And so this is a private landscape that I'm working on, but it's the pattern is what I'm showing. Well, in fact, we'll just kind of explain it, and then maybe we'll kind of skip through the video a little bit. But if you see, there's a dry spot right here, and there's a dry spot right here, and then there's a dry spot right here in front of me. So when you start to see those patterns, that's a sign that you have there's water coverage is the problem, and it's not a compacted area, and it's not a broken sprinkler. It could be a broken sprinkler, but usually it's coverage, and so you're going to make adjustments. So on this one, and I'll kind of skip ahead to maybe. So right now I'm kind of recording it, and I'm just pointing out some of those dry spots. But I fixed this head, so you can see that curtain is nice and high. And I point out that head I have not fixed. So the problem with this one is it's windy. In fact, I'll play the video for just a minute so you can hear the wind.
So the problem with these is that they have a low angled nozzle.
I'll explain it right
and it makes sense because there's a wind blowing, a little bit breezy here. You can see that flag up there blowing. So they put those low angled ones in to try and get underneath the wind.
So they're trying to get underneath the wind, so they put low angle nozzles in. But what it's done is this head with that low angle nozzle, and this one still had it on. I don't know if you noticed on this side, but it's really short. But it's spraying about 12 to 13 feet out. So I have about a 24 to 26 foot circle right in here that's getting watered really well by this head, but it's not reaching out to these. So we replaced the nozzle. We just put on a regular nozzle, so I have this good curtain. Now the problem will be is that I'll end up with kind of a dry ring around this head, but it will cover these. But that's okay, because again, we want the other heads to come down and cover this one. So this one's going to cover these 3 areas. And then the other sprinkler head's going to cover this one. So they're going to cover each other. But in this video, I go a little bit further because we talked about the patterns, but there's another pattern that I want to show that a lot of times when I talk about dirt, you have your irrigation patterns, but you also have sometimes just some dry spots that are causing the problem.
And now it causes this problem.
And we're going to skip ahead to that. When I start walking,
your system just to get covered. You focus on head-to-head water on it, if you don't have a lot of need. Check this out. So this one, you got 2 dry spots.
So this one could go either way. And what I'm pointing out is this dry spot and this dry spot and the green spot in between. And this is where when I sit down and actually watch. And sometimes this is when you got to get the measuring cups out. Is this could be an irrigation line, and I'll show this in the next video, but there's going to be an irrigation pattern that the spray might be spraying right in this area and overshooting and undershooting these 2 areas. Or it could be a compaction area where this is looser and then this is a little more compacted, so the water's evaporating and running off and going in these other areas and not onto the target area. And so I move, and so you can watch this video a little bit more fully. But I moved to show an example right here, kind of a compaction issue that I can see a little bit better. So in this area, you can see the sprinkler head that was right in front of me and the one across from me. And then there's a sprinkler head that's off to the left and to the right. So this is getting quadruple coverage, but I still have this dry look. And that's a lot of people get confused between the coverage, the broken sprinklers, and sometimes there's just debris. I'm jumping ahead a slide, I guess, but there's just debris or there's just compaction that will cause that same problem. So this one won't get fixed with irrigation. This spot right here and right here, all I do is keep increasing the irrigation until I'm tripling or quadrupling the amount of water that the rest of the turf needs to try and keep this viable and green. So the answer to this one is to come in and top dress it, to aerate it heavy, to slice it or to do something to decompact these areas so that it'll have the same green and the same coverage as this one. So this is, again, for a homeowner, it's going to be hard to identify. For someone that has a lot of experience in the landscape and irrigation, is identify those. I'm a big pusher on aeration. I think I said at the end of this video, and I don't show it, but I can usually aerate across the field. I can pull up a plug and say, all right, this is just extremely compacted. If it's moist, but it's shallow, it's compacted. If it's dry and shallow, then it's just not getting enough water. And of course, if it's pulling a big plug, it's easy. And then, like I said, maybe another video, another time, we can talk about diagnosing some compaction issues versus irrigation and that kind of stuff. But for the time frame here, I want to be able to cover it all. So look for patterns. If it's a triangle or a square or linear, then usually that means you have an irrigation coverage issue. If it's a single spot, then that usually means you have a broken irrigation. Not all the time. Again, I follow that 98% rule. But not all the time, but you might have one head that one spot's not getting covered well, but you might have some debris. Well, let's just go kind of that next line. Single spots could be irrigation coverage, and that's often the case, but it could also be a broken head or a broken line, usually less often. It could be compaction, which is actually often the case, and sometimes it can debris under the soil a little less often. So it could be all four of those. The one that I see missed a lot is the compaction problem, though, that people will have it, and they misidentify it as irrigation coverage, and they get frustrated because they can't seem to get enough coverage on that when they need to address that issue. So another video here. This one, I'll kind of skip through it again, play it. But this one, well, it's easier if I just kind of play it. And
okay, so this one you see the dry curtain.
Skip it here.
It's kind of on the lower.
Okay. Oh, and I mentioned, so you can see my little screwdriver in there. I mentioned that if you do your own irrigation DIY, you don't have all the professional tools. There's a lot of little different tools you need in it. Now you can see this one. So this one is the one I have and I'm pointing to. So it's an irrigation tool. So it's got a little cross on the top and a little screwdriver. Hunter heads, orbit heads, and some of those will have another different adjustment tool. So don't panic if you need to find or shop around and get an adjustment tool. If you just take a picture of it, take it into your irrigation supplier, they'll be able to say, this is the tool you'll need to adjust it. These are the kind of the head you'll need, or the different filters, or pretty much anything you do need. So what I'm pointing out on this one is, and it's kind of hard to see, is this curtain right here is hitting in this nice bright spot right here, and then it's falling short of this spot here. Now in the other video I showed two spots with the green in between. It's actually this dry spot that I was showing, and then one just off screen kind of in this area. And so that's more of a compaction issue in this area, and then this one's a dry spot, pretty much dry right here. But these are two curtains, so I'm playing and kind of following it.
Spraying out to here, and then the big part fits right in there, but it actually doesn't quite reach out to here, and it kind of overshoots. So this is where the main part, and that sprinkler curtain right here is hitting.
Now the next video I'm going to show is actually the new nozzle. So I just replaced the low angle nozzle with the regular one. But notice the curtain on this sprinkler. Let me kind of go back, and then when I show the next one,
curtain,
you'll see the same angle.
The lower part that's spraying out to here.
But you'll see a wider, higher curtain
there. But it actually doesn't quite reach out to here, and it kind of overshoots. So this is where the main part, and that sprinkler curtain right here is hitting. And then right below this dry spot is where this curtain below is hitting right here. So what we're going to do is this has a low angle here.
So then I walk
now,
out.
I don't really care if it hits this one here or not, because I'm going to use a different sprinkler.
I'm going to replay that because I talk about this area. I'm not concerned about this head hitting. I'm concerned about it. So this one, like I said, I'm kind of pointing out what I'm not concerned with this head is hitting this area right here. I'm talking in the video. I'm pointing out that this area in here I want to cover with a different irrigation head. So with this one, I'm more concerned about getting it stretched out to this area right here. And then I kind of go through and I'm pointing out, I think I walk out to the heads, is I want head-to-head coverage because that's going to cover that area. So I'm standing on this head, and I want that irrigation head right there to hit my feet. And I'm going to walk over to the other side. And I explain all this in the video, so if you guys look at it again, so this is the other head. So I guess I should record walking over. So then I walk over to this one, and that's the other head. So there's a nice triangle pattern. I got a head here. I got another head about 30 feet. to the other side, and I want to adjust that sprinkler so that it hits both of these heads. And in so doing, just adjusting it to hit that head there and this head near me, it's going to cover that dry spot. So the next video, so right in here, I think it was Paul just kind of showing that curtain coming across. So to compare it to a low angle to a high angle, a normal one. So now with that nozzle switched out, is this curtain on this irrigation is hitting this dry spot really well. This one, again, it's close to this one, but the other heads we adjust so that they're connecting and covering this one, and so all of it gets covered. So I don't have a picture. I'm actually presenting at UNLA at the Green Conference. I'm doing a turf class, and I'll actually have an overhead picture of this one where it shows the kind of green and all the irrigation adjusted and looks really nice. But that's kind of on this one. And then I talk quickly about just adjusting. So my finger here, as I'm talking about, this one is standing slightly this direction. And so you can manually, and a lot of times just covering that area, just standing your heads up and straightening them out, will take care of a lot of dry spots and will actually help the efficiency a ton. If anybody's gone out and done a water audit where you do the cups and put it out, you can put cups out and you can do a water audit and turn it on. And you go out and all you got to do is kind of straighten the heads and then you run it again and you can see an efficiency increase by 20 and 30% just by straightening heads. So on this one, I kind of just talked briefly about this at the end about taking that and rotating it, standing it up just a little bit better to kind of get it straightened out. But again, there's kind of a shot of that curtain right there and how it's covering that spot. So let's go to irrigation repair. So that's a little bit about just adjusting. Spend the time to sit back, relax, and do some adjusting. This is on campus. This happened last year, 2 years ago. We're mowing this grass. We hit a 4-inch riser. This was my worker that hit it. He got promoted, by the way. So he was I think he was he was full time, I think, when he did this, and now he's in charge of my sports turf. So if you make mistakes, a lot of times in my book, you learn from mistakes and you're going to get promoted eventually. So good culture, I suppose. But it's just kind of show off. Usually, when you got to repair irrigation, if it's a broken line. So that's what we start out with. I'm kind of going to skip over that part because it's easy to identify big broken lines or sprinklers because there's going to be a lot of water around. So a couple of secrets or just tips to the irrigation repair. If there's broken lines, dig it out thoroughly. Leave yourself lots of room to work. There's nothing more frustrating than digging it up just enough and then trying to repair a line or a head. So dig it up really thoroughly so you come in and work. If you're hiring it out, it's going to be a lot cheaper. You want to pay for someone for their technical skills, not their digging skills anyway. And if you're doing it yourself, it's going to save a lot of heartache. And then take a picture and take it to the irrigation store. They're going to get you the right parts and everything you need to repair it. And then I put a note down there because I think it's important. If you haven't done a lot of irrigation repair, there's pretty much a shortcut and a fix for almost everything. I'm going to go again with that 98% rule. There's always a 2% that you're going to find something odd that there is no repair for. But most everything, they're going to have something that says, yeah, we know what that problem is. A lot of people have it. Here's the parts you need. They can draw it out for you. They give everything you need. You go back and you can DIY brakes pretty easily. And I like to take this moment to say, if you're fixing something, use quality parts so you don't have to come back and do it twice, and use the opportunity to upgrade your system. And then after you kind of have the details, you can decide whether you want to hide it out or not. So this is most people are going to handle a 4 or 6 inch repair line, but just a couple pictures on campus of a bigger line that we're repairing on the main line. So real quick, shutting off the system. We're going to go by this one quickly, but if you guys our homeowners are not used to it so much, you have a water meter. You have a water meter that usually sits on one side of the sidewalk. And then you're going to have your stop and waste that will sit on the other. This is kind of a traditional way. A lot of the new construction won't have that one. And then you come in. So this is kind of that dividing line between city and between customer. Not the clearest picture, I apologize, but it has the sprinkler key in it. It shows kind of where that stop and waste is. And there's going to be that green lid you saw before. That's probably 4 feet deep into there. You're going to have this little sleeve and you stick it there and you can turn it off. So the valve key, you can shut off your system. The second one is usually a backflow. And the backflow is always going to have two ball joints or shut offs, and that's so they can test the backflow. But you can use either one of those to shut off the system as well. Traditionally, they're outside your house. They're by your house, so it protects it from irrigation or from getting hit by a mower or machinery. A lot of the newer construction, some things are even in the house. You can go down to your basement and you can turn the water off there. So outside or inside, those are quick to shut off if you have a major break and can break it, or excuse me, and need to shut it off to do a repair or keep it from flooding. So when I talk about upgrades, going back to this one of the major upgrades I'm talking about is manifolds. That's that back part of this irrigation system right here. Probably 15, this is 15 or 20 years ago, I did a repair for an American First Bank. And this was traditionally how they were built. So if you look at a system and it has this, if it's a new system, then the contractor either didn't know what they were doing or they're cutting some corners to save 10, 15 bucks, 20 bucks, I don't know. But if it's an older system, this is pretty common. And so if you ever have a break in a valve or in a line, you'll have to dig and probably cut all this out to replace just that one valve. And that's what happened this one experience is and it's not just one, it's happened a lot. But I went into an America First. They had a set of valves that were buried in the ground. They were all connected this old school way. I had to replace one valve. And I think there was 8 or 10 of them. And so I said, look, it's going to cost you $1,000 to replace because I got to rebuild all your manifolds, pull out all the valves, and kind of rebuild all this. I said I could upgrade it and put a new manifold in where if you ever have another problem with the valve, you can fix it for 20, 25 bucks, 30 bucks instead of paying $1,000 for every valve. And it costs like $100 to $200 more. So instead of a $1,000 job, we did $1,100, $1,200 job and we updated to a better manifold, which is something similar to this, where you got some connects where you can just unscrew the union. And if you ever have a problem with the valve, you can pull it out. Or if you have a problem with the line, you can cap it. Or if you have future construction, it's easy just to expand or to reduce or to do repairs. Another slide. So this one's put together with an action manifold. These are built local in Utah, I believe in Centerville. And then it just has the 3 valves and some good unions. But upgrade, anytime you need to repair, you might as well upgrade. And even if you don't, the irrigation system is a lot like a car. It's not going to last forever and parts are going to wear out. So it's not a bad idea if you have the budget to go through and just upgrade the system. Upgrade your nozzles, your heads, the clock. The clock should be updated. If it's a really old clock, if it's older than 10 years, you probably should update it because they have some cool clocks nowadays that aren't a lot of money. Backflow or internal components of a backflow should be updated every once in a while. Diaphragms and the solenoids and valves, those should all be upgraded. So if you're repairing one or two, take the time to check them all out. Again, so going over irrigation repairs, for the sake of time on this one, because we're already like almost to the question part. Broken heads and lines, dig it out thoroughly, take a picture, take it in and get it, and they'll set you up, the irrigation store. What we're going to focus on are valves not turning on and valves not turning off. And then slow seeping irrigation heads or drip lines or wet areas around the lowest point in the line. Let me show you how valve works real quick. So we're going to play this video. This is the Rainbird one that kind of shows the quick function of a valve.
Have you ever wondered how irrigation control valves work? First, let's take a look at the various parts of a valve. Here's a reverse flow irrigation valve that is in the closed position. The basic elements are the body, including the inlet, the outlet, and the valve seat, the bonnet and bonnet chamber, diaphragm, pilot flow filter, solenoid, and the solenoid dump cord. Water naturally flows into the inlet side of the valve, which is most often located on the side opposite the solenoid. Water fills the bonnet chamber above the diaphragm via the pilot flow filter, and the force of this water pressing down on the diaphragm holds the diaphragm in place. Notice that the larger surface area of water on the top side of the diaphragm has more force pressing down to close the valve versus the force on the bottom of the diaphragm pushing up to open the valve. There is also a path for water to fill the solenoid. The flow of water is stopped from flowing out the solenoid dump cord by the solenoid plunger seal, which is attached to the bottom end of the solenoid plunger. When the irrigation controller sends electricity to the valve solenoid, the solenoid coil becomes an electromagnet, pulling the plunger up into the solenoid, which allows the water in the solenoid and bonnet chamber to flow into the outlet of the valve. This lower pressure above the diaphragm allows the high inlet water pressure to push the diaphragm up, which allows water to flow through the valve. Once the flow of electricity to the solenoid stops, the plunger drops inside the solenoid, and the water stops flowing in the solenoid dump port. Eventually, the bonnet chamber water pressure becomes high enough to offset the water pressure below the diaphragm, and the valve closes.
Okay, so on that one, the focus that I want you to kind of just pay attention on that video course is the diaphragm, that pressure change. We'll go 2-3 slides, and I believe this is an hour long, so I'll show the 2 or 3 sides just to diagnose those, and then the rest maybe I'll present on another time because I go through some different sprinkler heads and some clock ideas. But the valve won't turn on 98% of the time. There's going to be 3 reasons, and they all have to do with that water pressure that's pushing down or not. If the valve won't turn on, the solenoid's bad, could be one of the problems. The clock isn't functioning correctly, or the valve wires are not connected. And there's 2 valve wires. There's a common, and then there's a hot wire basically to each valve. So the solution is, if the solenoids do wear out. So the clocks, if you have a modern clock, it'll actually show it as a fault, or it'll just skip it. And if it does that, you know the solenoid's bad. The pro tip is, if you're good at electricity and you know how to work a voltmeter, an amp meter, they operate at about 1/4 of an amp is what's flowing into that solenoid to cause that electromagnetic and pull that plunger up. If it starts to get higher than that, it is going to burn out. So if you start looking at one that's pulling 0.4 or 0.5 amps, I usually suggest just changing it out because it's going to burn out within a year or 2 anyway. Clocks do wear out as well. Sometimes they reset during power surges, and so you would just want to check, make sure that you have power to it, make sure that the program's on. That's actually what I'd start with. If you're not turning on, check the clock, then check the solenoid, and then check for corrosion in the wires. Or I'd check and make sure that if you get a wire nut that a contractor put on that doesn't have good goop in it, so to speak, where it's sealing off the moisture, it'll corrode. Sometimes they just work loose. You get a lot of traffic driving and you'll work a wire loose that's bad. If you previously nicked it doing a repair, it's usually going to corrode over time in that spot. If it's not one of those 3 things, then you're in that 2% area, and you probably want to check with someone that has a little more experience to fix it. Another 2 minutes here. So the valve won't turn off. This is the opposite. So number 1 thing is check to see if another program is running. A lot of the times there's an accidental A, B, or C, or D program that's running, and so you expect your irrigation system to be off, but it's on because you're just missing and you're not on the right program. So check the clock again. And then the diaphragm could be worn out. So just replace it. You can open it up. I was going to show you how to do that, but we don't have much time because I got a valve in front of me. You can just pull it off, pull it out, check it. Usually I just replace it because it's pretty cheap anyway. But if you see any cracking at all, just replace the diaphragm. Sometimes, it's not as often, but I have had it where a solenoid just doesn't close completely, usually because there's some sand in there, and it'll keep the system going. So if you tap it sometimes with just a screwdriver or a hammer lightly, not heavily, that'll close down, or you can just flush it out. And then occasionally there's a body that's cracked, and you'll just see water dripping from it. And so that will be 98% of the issues that keeps a valve from not turning off. There is that weird 2%, but again, if you're experiencing that, just have another experienced professional come out. And if you are that professional, you know what 2% I'm talking about. And then this will be the last thing so that I have time for questions. The problem with seeping heads, and I used to kind of ignore these because it wasn't a lot of water. And then I realized that there's probably tens of thousands of us that are ignoring just a little bit of seeping heads or a little bit of drips. And when you start to add that together, that's a lot of water that we're kind of wasting. And it just kind of went over. It's usually the diaphragm as well. Check the diaphragm, replace it, make sure the solenoid's clean. It's almost always the diaphragm or a crack in the valve. The pro tip is it's not the clock. If you have a seeping valve, there's a lot of times when people call me and I'll say, well, what's the issue? And I'll come out to fix it. And they always want to direct me towards the clock. And if it's weeping, it's always the diaphragm or the valve or something in there. So programming is the next step. Programming, and we're going to talk about sprinkler heads a little bit, but one of the secrets you got to be aware of is that the soil type and the sprinkler heads determine a lot of how you're going to program. The plant's going to require the same amount of water no matter what. So if you have a system that's putting out a ton of water, that plant just needs a certain amount. If you have a system that's only putting out a little bit of water, you're going to have to adjust your times and when, but that plant only needs a certain amount. So I hope this makes sense on that first couple bullet points I put. How long you water, how often you water is decided by the soil in the system. The amount of water is decided by the plant that you're trying to water, whether it be trees, flowers, or what. So the example I use is grass, because it's a simple one. Turf is an easy one we see all the time. So if a grass needs 2 inches of water per week during the hot summer months, then here are kind of the extremes. If you have a pop-up, and I'm going to go through these heads are the next slides. We're going to kind of go through and talk about the precipitation rate is what we're going to kind of talk about. But pop-ups, you may have a system that has pop-ups that's putting out a lot of water where you're only requiring 35 minutes per week to put down 2 inches of water. On the other extreme, you might have rotors that are going to take you 10 hours a week to put down 2 inches of water. Now, when I'm going to kind of go backwards, because I talked about the more overlapping you do, the better that is. That 10 hours usually isn't the case because we have multiple heads that are kind of overlapping. And usually the 35 minutes isn't the case. But those are kind of on the extremes, but just to kind of give you an example of the extremes. But either way, whether you're doing that 10 hours or that 35 minutes or somewhere in between, you're going to put down 2 inches of total water per week. So what I mean is we'll talk about rotors and impact heads briefly. But right here, this is a good one for big open areas, big turf areas. You're going to have a rotor or an impact head. And what I want to point out is we're going to kind of skip down to this area. There's the gallons per hour, how much water it's putting out, and it can be anywhere from about half a gallon to 14 gallons. And this right here, the precipitation rate can be different depending on what brand you're using. So these aren't hard numbers, but they're kind of in the area. And I don't know what I have under that picture, but ignore that. I think it's inches or something. But typical gallons per hour, 1.5 to 14 gallons. And there's a big range because there's a big coverage area. These can be covering anywhere from 20 feet to 50 feet. Some big commercial ones are going to go 80 feet, but somewhere in there. But the precip rate I've highlighted because that's what we want to pay attention to. The precip rate is basically how much of this water is actually falling on this particular place of the lawn. And that's in inches. So this could be a quarter of an inch that's falling here in an hour. It could be 1 inch of water that's falling here in an hour. 14 gallons is what's going through the whole thing, and that's probably actually per minute. I apologize, I got that down. Precip rate would be per hour, but the precip rate is what we want to focus on. Irrigation pop-ups. So if you pay attention to that precip rate, again, I think this is actually minutes. But the precip rate, if you look at it, it's 1.6 inches to 3.5 inches per hour is what that's putting down. But going back to the rotor, comparing it, you're 0.2 to 1. So go on the high end because that'll be easier one to think of. If you're putting 1 inch of water down per hour and you have a popper that's putting 3.5 inches down per hour, you're going to have to water this one to make them equal. To put down that same amount of water, it's going to be 3.5 times the amount of water or 3.5 times the length that you're watering. And then if you look, though, the radius isn't the same and the typical gallons per minute aren't the same either. Again, this is probably one you want to correct before we, that I might want to correct or something if we post it, or just make sure you take note. And then high efficiency nozzles. These are kind of the new hybrids right here. They do put down about 30% less water than, or waste 30% more less water than a traditional rotor or pop-up. So they're kind of a good one. But if you look at the precip rate, they're down to 1/2 inch. So if you're looking at this one, I get a lot of calls and deal with a lot of things where people are trying to water with this precip rate. So if you take, these math's going to be hard, 3.5 inches versus 1/2 inch. You're talking about this one will have to water, what is that, 6-7 times the amount of time to put down the same amount of waters of some pop-ups. So remember that not all nozzles, not all sprinkler heads they're not all equal. There's a precip rate that you got to pay attention to. So a lot of times people come out with recommendations and they'll say, well, just water for 20 minutes when they're referring to this precipitation rate. And you can't actually keep things alive with this one, with this precipitation rate, if you're only doing 20 minutes. This will take an hour and a half, 2 hours, or something else. But you're not wasting any more water. You're putting down the same amount of water. So you're adjusting your programming to the type of soil, and I'll talk about that one in just a minute. That's kind of what I'll end with. And you're also adjusting it to the type of system, the type of sprinkler head you have. This is more of the turf or the flower beds. There's also drip line. Love drip line. The only thing I don't like about drip line is I like to visually check. Like on USU, we have about 130 clocks. We have 2,000 stations, 30, 40, 50,000 heads. And so I like to be able to physically just drive around and see them. But if you're trying to keep irrigation water and conserve, then I love point source and drip line. So again, kind of going, and so I'm going to touch base on the soil real quick. And I'm going to come back down to this right, the examples. 2 inches of water per week, hot summer. So again, kind of the extreme. So this isn't exactly accurate. It's not going to be like this, but the extreme sides is if you have, now I put moderate clay because if it's clay, water's not going to go in. If you have a heavy clay soil, it's really not going to take too much. So moderate clay soil on the extreme end is you might have to cycle and soak. And you've heard that term where you water for a bit and then you turn it off for a bit and then you water for a bit. So it gives the soil a chance to take in the water. So if you have some clay soil on the extreme end, you might water for 3.5 minutes with a pop up, and you might have to cycle through that, do that every 2 hours, and do it for 1 night a week. And then you get 2 inches of water, you do it 1 night a week, and your grass thrives. And then you might turn around and have on the other extreme end, the sandy soils, where you're going to water 2.5 minutes twice per day, every day, because you have water that's going through the soil so quickly that you just got to add it so often. Either way you do it. So whether you're watering once a week, 3 times a week, or you're watering every day because your soil is demanding that you water differently, that amount should be 2 inches every week. And again, this is for turf during the summertime, so not 2 inches all the time, but 1 inch. But when we talk about efficiency and conservation, focus on the amount of water you need for that plant. You kind of know what the plant is and kind of what amount of water you need. Do a little research on the type of head you know, so you know how many gallons per minute, or really what the precipitation rate is. Make sure they're kind of overlapping, and then adjust that so that it's kind of getting that proper amount of water and it's all staying on site, not coming off. Now, real quick on the soil, and I think this is probably kind of what I'll end on a bit. Sand, loam, and clay are the 3 basic kinds. How I usually describe it, a lot of people know what I'm talking about, is you have the kind of soil that if you make it into a ball and throw it to your friend, or you would probably never throw it to your friend because it's going to knock him out if it hits him in the head, or it's going to leave like a welt and it's just going to hit and it's going to knock somebody over. That's clay soil. Loam is a type, if you make kind of a snowball ball of soil and you throw it, it's going to break apart into 4 or 5 pieces and they're going to fill it and then they're going to kind of laugh and everybody has a good time. That's why people like loam, is because it gets their attention but doesn't hurt anybody. If you do sand, you put it together, you throw it, and it just kind of explodes into a spray and it doesn't really have an effect. And then silt is the one that you kind of clamp together and you throw and it just comes back into your face. And so if you're trying to decide if you have clay, loam, or sand, you know, make a ball and throw it to somebody. If it stays together, it's clay. If it breaks apart a bit, if it's loam. If it disintegrates, it's usually sandy soil. To kind of give some guidelines. And then in closing, just a couple pictures of campus I love. This is an interesting spot. Low water, almost no water, and on a slope. And so this is kind of a fun project. Missed the willow structure quite a bit on campus, but that's good. So if you made it this far, thanks for hanging with me. And if you have any questions, we can ask a few more questions, and that's my email if anybody has any emails for me.
Let's see what questions we have.
Yeah.
How deep should the soil be tilled or replaced? So that's the question from Christine.
So it's a good question. I usually say is deep as possible. A lot of times you hear that grass, and I'm going to kind of go to turf because trees are going to grow roots as wide as the canopy, and they're usually going to go pretty deep. Not too, well, pretty deep. When I'm talking deep, a tree's going to be 18 to 24 inches pretty commonly. They usually don't go a whole lot deeper. So you don't need to go extremely deep for trees. For turf is what people start to get worried about. And the general rule is that the canopy is going to reflect the root system. But if you have good soil, that might be a little bit inaccurate. We have some turf that goes again on Old Main. We have turf roots that are going about 2 feet deep. When we excavate and we dig in there, we'll have a 3-inch grass and a foot and a half of just roots that just go forever. So that they're going to go where the water's at, and they're going to take the path of least resistance. If I was to make a recommendation, I'd say at least 6 inches on turf, up to 9 inches or a foot. And then in tree and shrub bed areas, I'd say 12 inches to 18 inches, 24 inches if you're really ambitious. But those are probably the general areas.
Okay, so the next question we have is I have what appears to be a good case of fairy ring in my yard. What is remedy for this? And Lynn, I will send you USU extension fact sheets with this, but then Sen, you want to tell something about this?
Sure. I mean, fairing, it depends on, there's a lot of different funguses that kind of cause it. And it depends on how bad it is. Most of the time, if you just fertilize and keep your grass green, it keeps up with it. And a good healthy turf can sometimes kind of push it around a little bit. And then there's a couple different, a heritage is one that I use that has an effect on quite a bit of them, but there's some different fungicides that you can put down to kind of take care of them. And again, USU actually has some pretty good information on that one. But 50% of the time I just fertilize and I just keep up with it and just make it look good. So it's only when I start to get a little bit of die out that I get really worried about the fungicide portion of it.
Yep. So I also sent her a link, so she should be getting it. Stephanie asked, why would only one head weep and not all of its valve?
Good question. It's always the lowest point on that line. Now, if you have some heads, there's some heads that actually will close off, so it doesn't allow the system to leak. A lot of commercial properties will have it, but it's usually a head that cost a few dollars more, so most residential homes won't see that. But the lowest part on the line, you're going to get just a little bit of water that's going through a crack in that diaphragm. So it's not enough to pressurize the whole system and pop everything up. And it just runs to the lowest point on the irrigation line, and it fills up that bottom part and it starts to leak out. So if all your heads are actually the same level, and there's no low point on the irrigation, it'll actually leak out of all of them eventually, kind of at the same time. But most of the time, there's just one head that sits a little bit lower than the rest, and will start leaking out of that one before it fills up the other one.
Awesome. So the next one is also would check valve head work to stop head drainage. Also
Yeah.
would, yeah.
Yeah, so that's what we're talking about. Is you can put that on.
Yeah.
Most residentials won't have them, so it's more of a commercial type thing when you start getting the check valve head.
Yep. And Brian asked, what is the best method to aerate turf?
So that's it's a loaded question, and so I take care of the sports turf on campus and the regular turf. So I'll just tell you what we do, what we practice, and what I do kind of on the side. For turf, just for most turf, it's going to be just a plug aeration. I do recommend the riding machines over a push aerator nowadays. Riding machines usually go 3.5, 4 inches, even up to 5 inches in depth. Where a walk behind machine, they max out about 2.5 inches. A lot of times it's only about 2 inches. The quantity is probably just as important as the type of aeration. On USU campus, we aerate 4 to 6 times a year with just a core aerator. I have somebody that runs an aerator every day. And then we have some troubled spots where we have more compaction, where we'll aerate probably 7 to 8 times per year, maybe even 9. On the sports turf, we'll aerate up to 20, 25 times a year. And we'll do deep tine aeration where we have spikes that kind of go into the ground, and then it kind of kicks back and almost fluffs it. We'll do core aeration. We'll do slice aeration. For turf in a residential setting, it's not quite as necessary. But if you're playing soccer on your backyard all the time, then you might want to do some spike aeration or a little bit deep tine or a couple extra aerations a year. So it really depends on how compacted it is to start with. And what I tell people when I do aeration on the side is I have it adjusted to 4 inches with 600 pounds of down pressure. And if I can't pull a 3.5 inch to 4 inch plug with that and the ground's moist, then I usually say, hey, you probably need another aeration because it's so more compacted. And you'll feel it when you drive over it.
Okay, good. The last one we have is Megan ask. I have seen a lot of blue tubing used in home irrigation system in new development areas around my house. Is this tubing superior to traditional PVC?
Um, yes, I mean, and it's a thick walled, flexible. Yeah, I mean, it's kind of the code now, and it is better than P. It'd be very expensive. Now, not the kind. There's some blue type that are thin wall that you can buy to actually do your residential system with. That's not superior. Is the tubing that's coming in from the street. That is designed to last a long, long time. It would be expensive to do a whole irrigation system in it, and it's not as flexible. So there's some good points and bad points to it, but yeah, it's a thick walled, highly durable. The one coming in from the street, the city one. Um, and then coming into the houses, sometimes there's a blue one that's more of a plumbing type instead of a PVC or a or an irrigation type one.
Yep.
To answer that one.